Assalamualaikum. My name is Muhammad Ramdhani Azlan. This number CD210280. Today I would like to be presenting about the introduction basis background. This method preserves the integrity of the material while enabling the examination and evaluation whether joint, part, or any flaws in built area. Any defect can be found using any technique, and depending on predetermined acceptance criteria, this defect can be accepted or rejected. The problem statement is students frequently don't get many chances to evaluate how non-destructive testing and DT techniques are applied in practical setting. Applying this technique exclusively to the condition is the main goal and assess how to find those affect the structural integrity as a whole. So the objective is to assess whether the structure using non-destructive testing entity method, and the step is to examine the evaluate flaws in different kind of specimen. So the scope, we have three scope, which is visual testing and liquid penetrant testing are the methodologies employed. The second one is the method is the subject of the inspection. The last one is the standard employed determine whether a flaw is accepted.
So here's all the methodologies. For non-destructive testing method, we use the visual testing and also the liquid penetrant testing. Here are the flow chart show that the first need to cleaning the well area, and then we use the inspecting for the visible defect like a crack. Vernier caliper we use for the accurate measure for any crack found, and then we use for the activity, which is the surface was cleaning first, and then followed by the red dye penetrants, and then after that like a dwell time like 10 minutes, and then we access dye was removed, and then we use the developer was applied to reveal the defects such as the crack and porosity. So the measurements were taken, and there was an area clean post inspections. So we can say that the both method actually help to detect the surface flaws early, improving the safety and also the component integrity.
Okay. For the visual inspection summary, the word appearance is uniform and consistent, and it is evenly spaced and no irregular shape or excessive reinforcement. This indicates the compliance with quality level C or better. For the detected defect there is a single surface breaking hole located at the center of the web. Estimate depth is 1 mm and it is classified as a blowhole. Next is the dye penetrant test summary. The dye penetrant test reveals a single surface breaking blowhole at the center of the web, approximately 1 mm in size. According to the ISO 5817, this is categorized under imperfection code 4012 single gas pore. Based on the observed size and isolated nature of the defect, the well meets quality level C, which is acceptable for the general mechanical and structural application.
Next, we move to the conclusion. The inspection of the welded sample was successfully performed using both visual testing and liquid penetrant testing (LPT). Both VT and LPT reveal the presence of the single surface breaking blowhole approximately 1 mm in size located at the center of the well bead. This defect is classified under ISO 6520-1 as imperfection code 4012 single gas pore. Based on ISO 5817-2014, the defect falls within the acceptable limit for quality level C, making the well acceptable for general, mechanical, and structural application. However, the well will not meet the stricter criteria for quality level B, which are required in high integrity applications such as pressure vessel or aerospace structure.
These recommendations are based on our inspection results using visual testing and liquid penetrance testing, where we identify a single surface breaking blowhole. Based on the results of our inspection, I would like to recommend several improvements Firstly, optimizing welding parameters such as current, voltage, and travel speed can help minimize gas entrapment that causes blowhole. Second, proper surface cleaning before welding is essential to prevent contamination that could lead to porosity. Third, it's important to use the correct electrode and shielding gas combination to ensure a stable arc and proper fusion. Regular inspections should also be carried out to detect any defects early before they become critical. Lastly, for applications that require higher structural integrity, stricter quality control measures should be applied to meet higher standard levels such as ISO 5817 Quality Level B.